calculus button, we want to go to evaluating limits analytically, and we're in that section right there. I need 21.4 to come up. There it is. Normally these buttons don't have any more than usually 3 problems assigned to each one of them. They come up randomly. I try to stick with 2, but usually 3, and very, very, very seldom there's 4 of them, but there is in this particular one here. We have given the limit of I sub t and f sub t. Find this limit. So this is what we're given, and this is what we want to find right here. Alright, that looks kind of confusing, but we'll get it worked out. So let's move over to the whiteboard. Bringing that up. What color could we use now? Guess we'll go back to blue. Let's see, what did we have? We had the limit as t approaches a, and I sub t is equal to 3. And we had the limit as t approaches a, f of t is equal to 13. We want to find the limit as t approaches a, I sub t plus 9 over f sub t plus 6. So what we can do here is we can break this up into the limit as t approaches a of I sub t plus 9 over, wow, that's a straight line. I about said lime. The limit, it's just LIM is how we abbreviate that. And then we have f sub t plus 6. Okay, and I'm going to put a parentheses around that, because what we're going to need to know how to do, what we're going to need to do now is we're going to have to break this up even further to where we have the limit as t approaches a. I hope I can write it all on this one line. I guess I will have to. Plus, and then we have the limit as t approaches a of 9. Okay, so that's the numerator. That line's not so straight there. T approaches a of f sub t plus the limit as t approaches a of 6. That's supposed to be an a, not an 8. I don't know where that got snuck in at. Now, of course, we can go ahead and substitute our guys in. So the limit of I sub t as t approaches a is 3, so this becomes 3. And so I don't have to scroll up the screen. I'm just going to continue this right here. How's that? So this becomes 3 plus, and the limit of a constant is just the constant. I think you've heard me repeat that over and over. We got the limit of f as t approaches a. We got that up here. That's 13. And then the limit of a constant is just the constant. Of course, that's supposed to be an a there. And that just becomes 6. So we end up with 13 over, whoa, that's 19. 13 over 19. 13 over 19. I wrote 16 there. So 13 over 19 is what we, that's not 13. Man, I'm not, what's going on here? Half asleep or something. That's 12 over 19, okay? So this ends up becoming 12 over 19. I'm sure when I got to this point here and clicked on the answer and it didn't agree with my answer, I'd be in big trouble. So there it is. All right. And that's going to be the last problem in this actual section here on evaluating limits analytically until I actually get caught up with the entire calculus course, and then I will add. So you should get a pretty good uh, I don't know, a fairly decent understanding anyway. If you've never studied calculus in your life, you're definitely going to be ahead of everybody else when you take the course, um, and actually, right, take the course. But that pretty much covers it for this section. We're moving on, I believe, to continuity in the next section. All right, we will see you there.